All right. I probably still have people joining, but I'm gonna go ahead and get started. First of all, I'm in my basement of my apartment, so hopefully, if you hear noise in the background, dogs, cats, kids running around, I apologize for that. But I wish I could turn the camera around so you can see what this really looks like. I threw these walls up over the last week, and this whiteboard kind of was stuck, so I had to throw together a studio. I know the lighting is really bad. There's some glare on the board, so I'm working on that. So hopefully you guys can see. Um, what I want to do today is I want to talk about simplifying logic circuits. What you can do is you can have a problem that you want to solve, a program you want to make in a PLC. You can write it out in English, and then you can represent the problem. You can represent the words as basically gates or logic circuits, and you can reduce those circuits to give you an efficient circuit or efficient program. You can translate the circuit to a program. So one way to do it, you've kind of already done. I think it was homework 6 where I gave you a Boolean expression. I asked you to reduce the expression using those Boolean laws, and you went through, and most of you did it correctly, but you can imagine the way you do it correctly, two things: you have to be familiar with the laws and a lot of practice, basically. So people can do that, but it'd be nice if there was a way that you can take a complicated Boolean expression. Remember, those expressions represent logic circuits, and they represent basically PLC programs. So it would be nice if I had a way where it didn't rely on how well or how familiar you are with these rules and laws. It'd be nice if I had a way where I could take basically any program or any logic circuit and reduce it down to the minimum, most efficient circuit. And so I want to introduce you to a way to do that using a method called a Karnaugh map, or we say K-map for short. So basically, a K-map is this is a 2x4 K-map, and all a K-map is a bunch of cells put together, but they use a particular code that we talked about a few weeks ago. That I'll remind you of that in a second. So if you have pen and paper, you might want to write this down. By the way, I'm recording this, so I'm gonna put this up on YouTube so you'll be able to replay it. Or if you ever miss one of these and you wanna watch it, you can go back to YouTube and you can see it. The only problem with that is if you have questions, of course, if it's recorded, you can't ask questions. So you guys can hear each other and you can hear me. So if you have a question, you can send a text message, but don't do that. I would prefer that you open your mic, speak into the mic if you have a question. I can't. The computer is so far away from me, so I can't see the screen on it. So if you send me a message by text, I won't be able to see it. But if you call in, I know I got 1 or 2 people that actually called in. If you call in, I don't know if you have the ability to ask questions or not, but hopefully if there's any issues, you can let me know. So take pen and paper, and there is a quiz, by the way, even though we're doing this thing from remote. I'll probably give you the quiz on Wednesday and have you turn it in to me through Blackboard on Friday. So it's going to be over the stuff I'm going over right now. So take out pen and paper, jot some stuff down. We'll do some practice problems, and that'll set you up for the quiz, and I think everything will be all right. So a K-map is basically just the construct of just these cells, and these cells in rows and columns. The simplest K-map I can have consists of basically a single cell, but you can't do much with a single cell. But the number of cells are a power of 2. So I can have a cell of 1. I can have K-maps composed of 2 cells, 4. I can't have 3, I can't have 6, I can have 8, and so forth. So as I said before, this is a 2x4 K-map. Now, what you do with the K-map is the size. You number the sides of the rows and columns, but you got to do it in binary. Now, this is important. I want to make sure you get this, because if you get this wrong, this numbering wrong, then everything's kind of screwed up. So here's what you do. We're going to start numbering the rows over here. We use 2 binary digits. So this first one is 0, 0, 0, 1, 1, 0 at the bottom. And you come back here, 1, 1. So in binary, this is a 0, this is a 1. You jump down here to 2, and then this is 3. You got to get that numbering exactly like I have it. Once you get the numbering exactly like I have it, you number the rows 0, 1, 2, 3. Now you number the columns. In this case, you just use one binary digit. So this is column 0, and this is column 1. Now the way the numbering works is you put this little bar over here like that, and you write these variables A, B, C. So draw that on your paper. Variable A, B, C. And now what happens is, right here, this is the value of A, this is the value of B, this is the value, no, I'm sorry, this is the value of A, and this is the value of B. So A is a 0, A is a 0, A is a 1, A is a 1. Here B is a 0, 1, and so forth. C has a value shown here for the columns. So each cell now has a value. The value of this cell, the binary value of this cell is 0, 0, 0. The binary of this cell is 0, 0, 1. And if you're doing this with pen and paper, go ahead and fill out the whole K-map with the binary values. This would be 0, 1, 0. This would be 0, 1, 1. This would be 1, 1, 0. This would be 1, 1, 1. This will be 1, 0 from here, 0. And then this would be 1, 0, 1. So 0, 0, 0, 0, and C is 0. This one, A is 0, B is 0, C is 1. This one, A is 0, B is 1, C is 0, and so forth. So one thing you got to be able to do is identify the binary value of a cell. Now, if you look at this long enough, you might notice something interesting. What's interesting is if you go from one cell to the other, only one of these binary numbers, one of these bits change at a time. So if I go from here to here, the C changes from a 0 to a 1. If I go from here to here, B changes from a 0 to a 1, and so forth. And if you remember, when we study binary numbers and codes, there was one special code we call it an error minimizing code called gray code, where you go from one number to the next and one bit changes at a time. So this uses gray code, and we're going to use this to minimize expressions, and that will come towards the end of the week. As you'll see, we'll actually apply this to a problem. You'll see how this stuff works. But now, what I want you to do is just act like we're playing a game. For this game, you're not allowed to ask why. If you don't understand something I do, so you can ask me about that, but don't ask me why. The why part of this is a whole other discussion. So what we're going to do here is I'm going to clean my K-map up. And what we're going to do is I'm going to put I think on the document on Blackboard, I put 1s in here, but you can put it whatever you want. So I'm gonna put some check marks in the K-map, and there's a couple rules to this game that we're gonna play. So before I talk about the rule, I don't know if you guys can see this. Can you see that? Does the camera focus on this? Can you guys see it?
I can see it.
Yes, I can see it. Yep.
Okay. If you can see this, this is like a K-map, and what I've done is I've numbered the cells, and I need to talk about something called an adjacency. So the word adjacent means right next to. So if you can see this, I can't see what my camera's saying because my thing is so small over there. My picture's so small. But number 1 and 5 are adjacent. 2 and 6 are adjacent. 3 and 7 are adjacent. 4 and 8 are adjacent. Those are adjacent cells. 1 and 2 are adjacent. 2 and 3 are right next to each other, either on the side or above and below. They're adjacent. diagonals are not adjacent. So if you can see, this is the 1 and the 6, they're not adjacent. The 5 and the 2 are not adjacent. So for an adjacency to be true, they have to be right across from each other or up and down. Now, there's something called wraparound, the term wraparound. If I take this, and I don't know if you can see what I'm doing, but if I take this, I spin it around like this and wrap it like a roll, like this. If I wrap it like that, then actually there's an adjacency between 1 and 4. If I wrap it around, the top of this and the bottom of this actually touch. So on this paper, 1 and 4 are actually adjacent because of wraparound. I can wrap it around like this, and they become adjacent because the edges touch. So you got to know what an adjacency is. Either the cells are right next to each other, above and below each other, or you can use what we call wraparound. The edge of this and the edge of this, they wrap around, and that makes 1 and 4 adjacent, and 5 and 8 are adjacent on this particular K-map, which is a 2x4 K-map. Now, next time we get together, I'll give you a bigger K-map, and we can have adjacencies the other way too, but we'll get to that in another time. So, 2 things you got to be able to do. You got to be able to number the cells. They're easy. The only way you'll get screwed up is if you don't get this number incorrect. You got to get this correct. It's not 0, 1, 2, 3. It's 0, 1. Binary 2 is down here, and then 3. And this is just 0, 1. You get that right, and you get all the binary values right. You get that part right, then you just got to remember what an adjacency is. The cells are right next to each other, above or below, or you can have an adjacency because you can do this thing we call wraparound. So the top of 1 and the bottom of 4 are actually adjacent. So if you understand that, what an adjacency is, and what happens is, I'll put something like this in the K-map. I'll put like a check mark. I think on the document, you might have one in there. I'll put a check mark here, and a check mark here. I'll put a check mark here. So these are called members. So I got 3 members here. What you got to do here is you got to circle. You're going to make groups out of these members. You're going to make groups. We're going to circle, and the way you circle them, you can circle 1 member. You can have a group. You can have a group of 1. I don't know if you guys can see that. You can have a group of 1. You can have a group of 2. You can't have a 3. You can have a 4. You can't have a 5 or a 6 or a 7. You can have an 8. These are all powers of 2s. So it has to be a power of 2. So the first thing is we're going to circle these members, but we want to circle the largest group that obeys this. I can have 1, 2, 4, 8 members. So if for this one, you want the minimum number of groups that have this number of members in it. And for the way I have it now, how many can I circle? How many of these can I circle that obeys that 1, 2, 8 number of members? How many can I circle? Well, I can circle this one. I can have a group of 2. I can't circle the whole thing because I cannot have a group of 3. As I said, there's always a power of 2. Now notice this one's here by itself. That one's there by itself. You can have a group of 1, so you might think, well, okay, what I'll do is I'll circle that one. But you want the largest number of members in each group. And it turns out that you can reuse a member. So even though I use this one right here, I can use it again. I don't want to circle that 1. I want the maximum number of members in the group. I can reuse it. I can reuse, so I can circle this one and be the correct grouping. I have 2 groups, and I have the largest number of members in each group. And I had to reuse that one, but that's okay. We can reuse a member. Okay, so now you might wonder, okay, where does all this go? Well, what will happen is, now what we can do is we'll write out the value, and I don't know if you guys can see this purple. So I'm going to write out the value like this group right here. Let me bring the line out. So this group right here, I got A, I got B, and I got C. One of these is going to drop out, and the one that's going to drop out is the one whose bit value in the cell changes. So what I'm saying is, for this group here, we're going this way. We're going across this way. if I'm in this cell, A and B have the same value, 0, 0. In this cell, they have the same value, but what changes is C. C changes from a 0 to a 1. Here, I have a 0, 0, 1. A is 0, B is 0, C is actually 0. So I have a 0, 0, 0. And here is A is 0, B is 0, C is a 1. So I'm looking for the 1. Only one bit will change. I'm looking for the 1 that changes from a 0 to a 1, vice versa. And since C changes, I can get rid of C. I can erase it. It's out of there. It's gone. Whatever variable binary value changes, you get rid of it. You throw it out. So for this one, C changed, so I eliminate the C. Then you got to go back and see the value. If I have a value of 0, I have to knot it. If I have a value of 1, I leave the variable unknotted. So I look in these cells and I see that both A and B are 0. When I show that, it's like this. I just knot it. If the value of A, B, or C in the cell is a 0, you put a bar over it. If it's not a 0, you leave it unbarred, unknotted. So I want you to try this one. On your paper, try this one. See which variable is eliminated, and then write out the term for that particular group. See if you can do that one. So for this one, I write out my variables A, B, C. So I'm moving up and down now. I'm going from this cell to this cell. There's no way that C can change. So I know C is going to stay there. So I'm only going to look at A and B to see which one changes state. Well, I see that B changes from a 0 to a 1. As I move this way, B changes from a 0 to a 1. So I'm going to eliminate the B. B is out of there. It's gone. Eliminate the B, and I go back to see if I have any zeros in there. Well, C is a 1, so it's okay. But look at A. A is a 0 on both cells. That means I got to knot it. Once you do that, and you put this together as one expression, and the expression will be written like this. This one, and you OR it with this one. Okay? So, I went through that kind of fast, but if you downloaded the document off of Blackboard, then you have, I think you have like 4 or 5 of those I gave you. We're going to practice with those. So if you have that document, take it out. If you don't have it, don't worry about it. I'll put it on the board. You can just write it on your paper. But I want you to look at that document. I think they're labeled A through E or something like that. Try to group the members for KMAP A. Now put ones in there instead of checks, but it doesn't matter what you put in the box. So take that paper out. If you don't have it, I'll put it up on the board. I want to see if you can group it. Now remember, you want the largest number of groups, the largest group that contains this number of members. The idea is to get the fewest number of groups. So it's kind of got to do it, and you can kind of see it. It's pretty simple once you see what we're doing. So I'm going to erase this. So remember these numbers. I'm going to get rid of this. I'm going to put that first KMAP up here, but I'm going to give you a chance to try to minimize it. If I can find out what I did. All right. All right, so here's what the first one looks like. Okay, so there are my members, and then you got to number it. 0, 0, 0, 1, 1, 0, 1, 1. This is 0, that's 1. And then you have A, B, and C. All right, so I'll be quiet. I want you guys to see if you can group it. See if you can group this. How many groups you have? And then we'll get the variables out of those groups. So you should have, you got a group here, and you got a group down here, like that. Now, there's a lot of ways you can group this. You could have grouped these two together, and then you could try to, but what you want, if you just remember, you want the fewest number of groups that contain the most members. If you obey those two rules, or whatever you want to call them, then you'll end up with this K-map the way I have it. So the only way to get the fewest number is to do it with the biggest number of members is to do it this way. And if you got these two groups, this green, I got A, B, C, and I'm going this way. Anytime in a 2x4 K-map that you move horizontally, C is going to be the one that drops out. So C drops out. I check for zeros. I see A is a 0, B is a 0, so I got to knot these. So these are knotted, and that's for that group, that's what I get. And then for the purple group, I got A, B, C. This time I'm moving this way. In a 2x4 K-map, if you move straight up and down, C stays there. So C is going to be there. So I got to look at A and B to see which one changes. I see that B changes from a 1 to a 0. So B is gone. And I got to check for zeros. A, 1, 1, so A is okay. But C, look at C. C is a 0, so I got a knot. So the expression I get for this is A, B, not, or A, C, and we usually set it equal to some variable like X or Y. So here's the minimized expression for that K-map. Now, if you're wondering what you can do, well, I'll show you that later. I don't want to get ahead of myself. So we'll just practice this for now. So hopefully you came out with that. If you didn't, move to the next K-map, B, and set it up, number it, group it, and try to give me the expression from K-map B on your paper. Guess I can make a little bit better use of my board. Make it a little bigger. That K-map looks like it's on a crack or something. It looks terrible. Kind of hard to draw a straight line on this board. All right, so we got that one and that one. And then you put your numbers in and your variables. Okay, so see if you can see how many groups you get from this one. if you have coloring pens or pencils, which you guys should have from class, it comes in handy for the next couple of lectures. You probably want to get those out. It'll help you out because this gets a little, we'll get bigger. We can do this. You can do, this is a 2x4. We'll do a 4x4. And after that, it goes to 3-dimensional. It looks like a Rubik's Cube type. It gets really complicated after you go above a 4x4. But coloring pens or pencils actually help you solve the problem when we start using this stuff. So I want to group these. I want the largest number of members in the group, but I want the fewest number of groups. So you might think, well, I can get a group of here and here, but remember, you can't have a group of 3. You're not allowed to have 3. So the way I see to group this is I can have a group of 2 right here. I can reuse this one and get another group of 2 right here. And then I can have a group of 1. I don't know if this red is going to show up on camera, but hopefully you can see the red. So I got a group of 1 right there. Now, a group of 1 is simple because you're not gonna lose any variables. If I stay in this cell, nothing drops out. So all I gotta do is check for zeros. And I see that these 2 are zeros, and that's a 1. So that's a 0, that's a 0, that's a 1. So I leave it unbarred. So all we gotta work on is the blue group and the green group. So see if you can do those. Do the green one first. I got A, B, C. Of course, anytime you move horizontally in the 2x4 K-map, C is going to be the one to drop out. And A and B are 1, so I'll leave it unknotted. And all I got now is the blue group. So for the blue one, A, B, C. C is a 0, so I knot that. And I see as I move up and down, A changes, so I take A out. A is gone. And B is a 1, so I leave it unknotted. And then what you do is take these 3 terms or them together to get your expression. So here is A, B, C, not, or B, C, not, or A, B, and these are unknotted, equals X or Y or something like that. Okay, so that is the second problem, B. I'll move to C. I'll be quiet for a minute. C is they get a little bit more interesting as you go from one to the other. So I'll give you a second to work on C. Go ahead and write out the K-map for C. Put it in your grouping and see what you come up with. So if you're doing this problem, I see a group of 2 here. I get another group of 2 if I reuse this one. I got another group of 2. And then I got that single group of 1. So I got 3 groups. And then if I get my variables, a group of 1, I don't lose any variables. I'm in that first cell, they're all 0, so I bar all of these. For the purple group, if I move up and down, that means C has to stay. So C is okay. It's a 1, I don't have to worry about it. It's going to be either A or B to drop out. I see I move from this cell to this cell. It's A that changes from a 0 to a 1. So I get rid of the A. And I check for B. B is a 1, so I leave it unknotted. So for that one, I got BC. And then the green group, I'm moving horizontally, which means that C is out of there. And I got 1, 1, so these stay unknotted. You order these out, set them equal to X, Y, or Z, and you're good to go. So that one wasn't too bad. That was C. But now D is pretty interesting. So look at D. Let's do D. I'm going to give you a second to do that one, because that one you got to think about. If you can get D, then you really see what's going on. And you'll do well on the quiz I'm going to give you on Wednesday. The way the quiz is, I'll give it to you on Wednesday. You don't have to give it back to me until Friday. You'll have, and you can, I don't care if you talk about it. I mean, you guys can talk about it. I just want you to learn how to do it. So if you talk about it, say, hey, what did you get? You want to argue about it? I just want you to learn it, and you should be good to go. All right, so D. All right, I think I got it correct. All right, so see what you can do with this one. There's a lot going on here. How many groups do you see? How many groups you think it is? Anybody?
4.
4.
4 groups. Somebody else get something different?
I'm seeing 3.
Can you all see what I write right here? Do you see that light spot? Can you see it? Can you see that 4?
Yes.
Yeah.
I got a fluorescent light right there. I don't know what to do with it. It just drives me crazy. So somebody said they saw 4. Somebody said they saw 3. Anybody get something different?
I've got 6.
6. Somebody said they saw 6. Okay. Well, how do I get the biggest group? Which one's the biggest?
Wouldn't it be the top and the bottom too?
Exactly right. So whoever that was, I can't see my screen. He's using the idea that I can take this and 1 and 5 and 4 and 8 are actually adjacent because I can bend the K-map around like this. So I can have a group of 1, I can have a group of 2, I can have a group of 4. So using wraparound, I can group these two with these two if I bend that K-map around. So that's one group. And then I have a group, I can reuse that with that one. So there's a second group. And then I can do the same thing right here with that one. I can reuse that one. Here's a third group. So whoever said 3, you're right on it. If you didn't get this, look at that and make sure you understand what I did. So you might have forgot about that wraparound. You can wrap these around, and we get more cells in here. You tend to do that more and more and more. There's a lot of wraparound going on. But for this one, you actually have 3 groups. One big group of 4 and 2 smaller groups are reuse this bit and that bit. So study this map and make sure you understand how we get there. Now the thing about a group of 4, anytime you have a group of 4, 2 variables will drop out. So you got to be a little careful here. So for this group of 4, what I'm going to do is write A, B, C. Well, automatically when you got a group of 4, unless you have 4 in one whole column, I got a group of 4 here using wraparound. I got to go this way, which means C is out of there. Moving this way, either there or down here, C is out. It's gone. So you might as well get rid of that to keep it simple. And then all I got to do is look at A and the B. So I see here in this cell, which is part of that wraparound, A is a 0, B is a 0, but down here, A is a 1, B still is a 0. So A is the one that changed from a 0 to a 1, so I got to get rid of the A. And the only thing I have left is B. And since B has a value of 0 in both of these rows, I got a 9. So anytime you group 4 cells, you get 1 variable. So that's that one. Now you do the other 2, and then we'll move to, I guess the last one, E, which is another interesting problem. I would say if you can do this one and E, then the quiz will be a piece of cake for you. I think I'll put like 5 or maybe give you 4 or 5 K maps, some simple ones and some bigger ones. And then we'll see what you can do with those. The purple one, we do the purple one. I'm moving up and down, so C is going to stay there. I'm moving up and down, so my C is a 0, so I nod it. And B is the one that changes, so I get rid of it. A is a 0, so I nod it. And then the red one, my red group, I'm going to keep C because I'm moving this way. So I'm looking at A and B. I see that B is the one that changes from a 1 to a 0. Get rid of the B. And I see that the A and the C are 1. So what I get is B naught or A, C bar bar or A, C is equal to some variable. And the order, of course, the order doesn't matter. You can OR things together in any order, it doesn't matter. So that's a pretty good problem right there. I like that one. That's a good problem. It forces you to use all the rules. Okay, so we got one more. D. Is it D? No, it's E. We just did D. So try to get E. I'll give you a few minutes to think about how to do that. And then we'll call it a day. We'll wrap it up a little early. I think we'll be done early. Unless you have questions, of course. But let's put that one on the board in case you don't have a paper. You can look at it. I'll put it on for you. I think I got them. All right, so I'll give you a few minutes. I'm gonna walk out of the camera because it's dusty down here, and I'll be back.
So how's everybody's morning going?
Dude, I'm still in bed.
So tired. What's up?
So this one is a little more interesting, as I said. So you could, well, you tell me, what do you think? How many groups? We got a lot going on here.
Yeah.
The easiest one.
Would it be just
Say
two?
it again. Somebody said 3. Anybody get something different?
2?
Somebody got 2? Really?
Sam, I think it can't be 2 because you can't get a group of 6, but you can get a group of
Gotcha.
2 groups of 4, and then the line 4.
Gotcha.
Okay, so the easiest one to see, I think everybody agrees on this one, right? Does everybody agree on this one?
Agree.
Yep. I agree on that one.
And then the next one would be these, all right? But that leaves this one out. Now you might think, well, I can circle that one, but remember, we want the largest number in each group. So it feels a little weird to do this, but actually what you want to do is this. Wrap it around. Because you don't want to circle that one. The more group, the more members we have in the group, the more variables drop out. And that's what we want. We want things to drop out. Remember, every variable that drops out represents code in your PLC program. So everything you can get to drop out means your code is simpler. So you don't want to circle that 1. I can reuse all of these bits and use wraparound to circle a group of 4. I'm going to kill a lot of variables doing that way. So whoever said 3, you're right on it. Dead on. So let's see if we can, it's 9:50. What time is it? Well, let's hurry up and do this. I don't know if I had a session scheduled to end. Hopefully it keeps going. I don't know what happens when you reach the end time, but let's do this real quick. So this one's A, B, C. Now remember, anytime you have a group of 4, you end up with only one variable. So what drops out here? Well, as I move this way, C's out of there. It's going to be either A or B. So I'm moving up and down this way in the purple group. B changes from a 0 to a 1. So B is out of there. A is a 0, so I got to knot it. So for my expression, I got A knot for the purple. And then I guess the green one is the easiest one to do, so we'll do that. Well, that's really easy because if I move up and down a whole column, A and B are dead. The only thing that's left is C. And since it's a 0, I got to knot that. So or C knot. And then I do my wraparound. I'll do it down here if you can see it. I got A, B, C. Well, the fact that I can go like this on the top and the bottom means that C has got to drop out. C changes from a 1 to a 0. So we just got to look at the A and the B. Here, A is a 0, B is a 0. Here, A is a 1, B is still a 0. So the A drops out. I'm left with B, which is a 0, so I knot it. So I actually end up with A bar, or B bar, or C bar equals X. And that will be the simplified expression for that K-map. That was a good problem. I like this one too. So hopefully you kind of see what's going on. If not, don't worry too much about it. When we do the next session, which will be Wednesday, same time, we'll practice some more, but the K-map will be bigger. If you go on Blackboard, the map's already up there. We're going to do some 4x4s, and we'll stop at 4x4. You can go higher, but then we got to use the three-dimensional thing. I don't have enough room, and you don't have enough time, or I don't want to do it. So we'll just do a 4x4. If you can get that, I'll be satisfied. Anybody have any questions for me before we disconnect? If you do,
Hey,
say again.
how you been doing?
Oh man, that's a really good question. First of all, I spent I know it doesn't look like much, but I probably spent about $500 trying to throw something together because I didn't have the ability to do the video at home. So I got a cheap webcam, and that's been like a week and going, putting this thing together. Then I found a stray dog. I'll show you on camera next time. I already have 6 pit bulls. I don't know if you guys know that, but I saw a long-haired Chihuahua walking up. I live on Reading Road. It's a little tiny Chihuahua walking up. So if you look on Craigslist, I have an ad out for that, trying to find the owner of this dog. The dog's actually chipped, but the information, when I took it to the vet, the information is no good. So now I got 7 dogs. And then I'm trying to, like you guys, I'm trying to avoid this virus. I think you guys know I take care of my mom. She's almost 80, so I don't want to bring that home to her. So other than that, I say I'm doing all right. So staying safe. Karan, I don't know if you're out there. Are you still there? Or did you sign off? He might be gone. I wanted to know if he had food. He always has food in the classroom. I guess I'm doing all right though. Thanks for asking. I'm gonna sign off. You guys have a great rest of the day. I'll see you the same time on Wednesday. I will put this up on YouTube and send you the link if you want to rewatch it, or if you know somebody that missed it, they can go to Blackboard and look at it. So you guys have a good one, and stay safe, and I will see you on Wednesday, same time.